Types of hypothesis tests expands on the fundamentals of statistical inference by introducing the major hypothesis tests used in quantitative financial analysis. The topic explains that different testing methods are appropriate depending on the type of data, the population characteristics, and the parameter being evaluated. Financial analysts use hypothesis tests to assess expected returns, compare investment performance, evaluate economic relationships, and analyze market behavior. Choosing the correct statistical test is essential because inappropriate methods can lead to invalid conclusions and poor investment decisions. The topic emphasizes that hypothesis testing provides a disciplined framework for evaluating evidence and drawing conclusions under uncertainty in financial research and practice. The topic begins with tests concerning population means, particularly z-tests and t-tests. A z-test is appropriate when the population variance is known or when sample sizes are sufficiently large. In practice, however, population variance is often unknown, so analysts frequently rely on t-tests, which use the student's t-distribution. The t-distribution resembles the normal distribution but has heavier tails, reflecting greater uncertainty in smaller samples. As sample size increases, the t-distribution approaches the standard normal distribution. The topic explains that one sample tests evaluate a single population mean, while two sample tests compare means across independent groups or paired observations. The topic also discusses hypothesis tests involving variances. Variance tests are important in finance because volatility represents a major component of investment risk. Analysts may test whether portfolio volatility differs from a benchmark level or compare risk levels across investments. The chi-square test is used to evaluate hypotheses concerning a single population variance, while f-tests compare the variances of two populations. These tests are especially relevant in risk management, asset allocation, and portfolio construction because they help analysts assess whether observed differences in volatility are statistically significant rather than the result of random variation in market returns. Another major topic in the topic is tests involving proportions and categorical data. Proportion tests evaluate the likelihood of specific outcomes within populations, such as default rates or the frequency of positive returns. These tests are commonly applied in credit analysis, survey research, and behavioral finance studies. The topic also introduces non-parametric tests, which do not require strict assumptions about underlying population distributions. Non-parametric methods are particularly useful when sample sizes are small, distributions are highly skewed, or data are ordinal rather than numerical. The topic emphasizes that selecting appropriate tests depends heavily on the characteristics and quality of available financial data. The topic highlights the distinction between parametric and non-parametric testing approaches. Parametric tests assume specific population distributions and often provide more powerful statistical results when assumptions hold true. Examples include z-tests, t-tests, chi-square tests, and f-tests. Non-parametric tests require fewer assumptions and offer greater flexibility when data violate normality assumptions or contain outliers. Analysts must therefore evaluate the suitability of assumptions before selecting a testing method. In financial markets, where return distributions may exhibit skewness, kurtosis, and extreme observations, understanding the strengths and limitations of different hypothesis tests is particularly important for maintaining analytical reliability and accuracy. The key concepts from topic provide a practical framework for selecting and applying statistical tests in finance. Different hypothesis tests address different analytical questions involving means, variances, proportions, and distributions. The topic reinforces that accurate statistical inference depends on choosing methods consistent with sample characteristics and underlying assumptions. These testing procedures support many advanced applications throughout the CFA program, including regression analysis, portfolio performance evaluation, economic forecasting, and risk modeling. Mastery of hypothesis testing techniques enables investment professionals to interpret empirical evidence rigorously, evaluate financial claims objectively, and make more informed decisions in uncertain and data-driven investment environments.